what we. So the key part was a definition of functions sine and cosine. And those are ones that I really need you to keep in mind, because that definitely is very helpful. So for any point on the circle with a radius 1, or unit circle, we can connect this point with a origin and produce angle measured theta. From now on, they like to use letter theta for measure of angles. And then there'll be two coordinates of that point on a unit circle. So the x coordinate will be called cosine of this angle theta, and y coordinate will be called as a sine of this same angle theta. So it's just x, y coordinates, that's all it is. And that's what they actually tell us here. They also refresh our memories on how we produce other trig functions, such as a tangent, and that's a quotient of sine over cosine. And then reciprocals of those three functions, such as a cotangent theta, and that's same as a 1 divided by tangent. So what I do is just flip that expression for tangent that we had above and produce cosine on the top and sine function on the bottom. And there are also two more, such as a secant theta and a cosecant theta. And we produce them analogously by doing the reciprocal on cosine and sine respectively. So we got 6 trig functions, but I guess only 2 is what we really need, because other 4 automatically come out as various results of dealing with sine and cosine. And I guess that's good and important to realize. So other things that this section is talking about is the, so now here they decided to call this angle with theta instead of t. Well, I guess that's pretty much all they're talking about here. Instead of variable, you can put just about any value you like, right? So it's up to you. So that's what we did back in section 6.2. So it's a little refresher. I know long weekend, people might lose track a little bit, which is completely understandable. And then looks like we are moving to the next section that actually repeats again the same story, section 3 of chapter 6. And the problems are going to be also very, very similar. And you can see again those favorite 6 trig functions, sine, cosine, and so forth. Here's one interesting statement that says that sine is in between of negative and positive 1. And the reason this is the case is because on the unit circle, the sine is y coordinate, and we cannot get outside negative and positive 1 for any point on this circle. The y coordinate always going to be in between. Analogously, for the x coordinate, same thing, in between of negative and positive 1. So I guess geometric pictures always give you a good intuition into what is happening, so you don't really have to memorize anything. So other things they talk about is so-called period of function. I guess that's another interesting observation we can make by looking at favorite unit circle. So if you decide to rotate this angle theta by full rotation or 2 pi, you're gonna return back to exact same point. And that's what they're saying, that if you add 2 pi, then sine and cosine will stay the same. So people say the period of these functions is 2 pi. And the other periods we're going to discuss a little later when we start to do graphing. So here's the set of formulas that I just listed for you, 6 formulas. You can see them in this 2 and 3. So my message is they just repeat the same thing again in this section. And I think a reiteration is good to have. Now we also encounter so-called Pythagorean identities here that talk about our favorite sine squared and cosine squared equal to 1. And I think we also saw that tangent squared plus 1 is secant squared. And cotangents with cosecants also give us the same exact relationship. I don't want you to memorize them because they're all at the same last page of the textbook, and I think it's good to have it available. So if I just prepared, made another copy of this textbook, if you don't have one as of yet, I'm gonna gladly share it with everyone right now in chat. So if you remember at the last pages of this textbook, there was important collection of these formulas that actually present on that section. So if you go down a little bit, you're going to see some of these so-called identities that we just saw. And there are also even odd functions that definitely worth to consider. So let me maybe go to a little bit more room here and try to make a picture of my favorite unit circle, of course. And I don't have any favorite pictures for this class anyways. So if you again look at the definition of function cosine for the angle theta, and if you also consider the negative angle theta minus theta, then what should happen, maybe it's not that clear for my picture, but the values for cosine are going to be the same. So cosine of angle theta will be exactly the same as a cosine of a negative theta. And that's what people say makes this cosine to be even function. That's actually, I guess, next group of formulas that talk about absorbing the negative sign or sometimes spitting it out. So these are so-called even odd properties. And here's the one for cosine that I just considered. With respect to function sine, you can notice that sine of theta is here, right? But if you look at the negative angle theta, its y-coordinate is going to be with negative sign. So they are not the same. They seem to be, people say, same in absolute value, but they're opposite in sign. So if I want to consider value of sine function of negative theta, then with respect to my angle positive theta, is going to have different sign. So if you look at this, minus is going to come out. And that's what actually picture says. So instead of going down, to go up, you need to change the sign, and that's what minus in front takes care of. That's worth to think about, because I guess these things are ones that will be used every once in a while, not too often. That's why I don't jump much at these, but I'd like to do some problems here in the section so we can practice with a few exercises. So how about problem number 35? That's a recommended exercise here. please notice that 35 gives you both n sine and cosine. So in exercise 35, they say that sine is -3/5, and the cosine is also given. It's a +4/5. Okay, good start. So I need to get 4 remaining trig functions. They say get all 6 of them. So I need to start with a tangent and continue. So if I divide -3/5 by +4/5, then I will be taking care of this denominator's 5, right? That's the part that is something that I want to cancel. So I'm going to multiply and divide by 5. So these denominators going to simply disappear like that. And whatever is left over will be my little answer. It looks like the answer will be with a minus sign. So this is a -3 on the top and 4 on the bottom. So that minus people usually just bring in front. So just divided 2 fractions, and whatever came out is the answer. Now, for the fact that we have a reciprocal that is cotangent, I can right away flip that 3/4 and get 4/3, but the minus is still going to be with us, right? So we just take a reciprocal. And the same thing you'll do with a secant. You just take that cosine 4/5 and turn it into 5/4. You just switch numerator, denominator, people say flip it, that fraction. And analogously with the last one. So you get -5/3. So I guess this is just a bunch of writing things down, and you can do it a couple of times. And I think it's really not worse to do lots of problems in this group, because you're going to be stuck doing the same thing, 6 functions. It's a little bit annoying, right? But if you do it a couple of times, that'd be plenty. So I can try another one here. Let's say, how about number 46, for example, where they give us a little less information. So instead of giving us 2 of these functions, they just give us 1. Yes, Alex, you're doing 43, not 46. Okay, I can do 43. I think that's another good exercise. It doesn't matter. They're all pretty much same. So sine theta is 12/13. And now I need to find cosine of theta, right? So to find cosine, I'm going to recall that Pythagorean identity that says sine squared plus cosine squared is equal to what? 1, right? So if you need to find sine, then you can bring cosine squared over to the other side. And then extract the square root, so you don't have just square with sine, but just a sine of theta. But of course, it could be either positive or negative. So there's always question, what is your sign for that particular case? Is that plus or minus? And for that matter, they gave us a little extra information here. They told us the quadrant. They said it's a quadrant number 2. So we're someplace here, right? Here's the first quadrant. This is second quadrant. Did you ever see that? Third and the fourth, going counterclockwise. So if we're in the quadrant number 2, notice that value of cosine is going to be negative. So our cosine theta is going to be with a minus in front. See, that's why people say it could be plus or minus, but it doesn't mean that it's both. It means that it's either plus or a minus. That's why I deliberately don't put the sign. It depends on the quadrant. And then I can put in this formula instead of, oh, let's see, sine is 1 minus cosine, but if I'm given sine, then I can also write that analogous formula, but is going to be also square root from 1 minus sine squared, right? So it depends what you print to one side and what you leave on the other side. So it's analogous, but again, we just figured out that we have to put a minus in front. So I wasn't very careful. And I have to utilize that 12/13 here, okay? We're gonna need to square it and see what we're gonna get this way. So 12/13 squared is 144 over 169, isn't it? So what happens when I subtract this from 1? Well, I need to turn number 1 with a fraction that has the same denominator, 169, and numerator is also going to be 169. So notice when I subtract from 169, 144, that's exactly 25. How about that? Over 169. And again, I forgot to put a minus in front. It's a good idea to keep it there. So we square root 25 is 5 and 169 is 13. So there we have it. We found the value for cosine function. And now we continue with the other remaining 4 functions, exact same way as we just did in the previous little exercise. So I can clear this mess, and instead of sine and cosine, now I have a little different numbers to put in. And that's good. So I'm gonna use whatever they have here. So they say that sine is 12/13 in this exercise, right? Okay. And the cosine we found is a negative because it's in the second quadrant. It's minus in front of 5/13. Great. So it looks like 13 I'm going to cancel. So people usually don't put 13 on the top and on the bottom. They just say, okay, we're going to cancel these denominators, 13s. Again, why? Because if you times by 13, the top and the bottom, that will make it go away. And this gives us negative in front of 12 over 5. Hope you can see it here. So once you have found tangent, right away you flip it. So you put minus and then 5 over 12. And this is your cotangent. So you just flip it. And same thing you do with the others with secant and cosecant. So secant is 1 over cosine. So here's my cosine, negative 5/13. So it's still negative, but now 13 is on the top and 5 is on the bottom, right? And finally, I reciprocate my function sine, and this is 13 over 12. So looks like once you have your sine and cosine, you don't really need to continue, because basically just divide and flip, and that's a little bit of algebraic tricks. So I don't think you need to worry much about this. So let's try something with that radians, with pi, because that's probably worth to take a look at. So how about exercise number? I just want to do today sines and cosines. Next time I'll do the other functions. Because again, turns out once you have sines and cosines, then the other trig functions automatically come right out. So we should know pretty well sines and cosines. So let me try number 19 here. They said good idea to try with pi. And turns out that this exercise will use the fact that period of function cosine is 2 pi. In other words, if you do the full rotation, then, well, you get the same thing anyways. So if they want to look at 33 pi over 4. So how can I work on this? Well, it turns out that multiples of pi over 2 are good. And that's why I'm going to write this 33 as 32 plus 1, because 32 is a friend of 4. 4 times 8 is 32. So I can actually break this into 32 pi's over 4, and also pi over 4, right? So I just separated 1 pi over 4 here, because this way I can actually take care of my first piece and just get 8 pi. So what does that stand for? Well, 8 pi, 2 pi is rotation all the way around, 4 pi is another rotation, 6 pi, and finally 8 pi, right? And then there is only pi over 4 left over, so it'll be something like that. If I rotate by pi over 4, like 45 degrees, right? So if they want a cosine, well, we can give them cosine, because this is same as a cosine of pi over 4. And this is equal to, I memorize this, square root 2 over 2. Of course, people say, Alex, there's no way I can memorize this. And you don't have to. You can just take a look at the last page of this beautiful textbook and get this circle and a diagram. And on that circle, you can locate angle pi over 4, which is corresponding to 45 degrees. And here's the point that we're concerned with. So cosine pi over 4 is here. It's x coordinate, remember? See, that's all we have to remember. X coordinate is cosine, y coordinate is sine. So both of them are the same, and they both are radical 2 over 2. So whenever you deal with 45 degrees angles, it's square root 2 over 2 stuff. So now, I guess I can do one more, and then maybe you can try one. So how about if I try exercise number 12 with degrees? Maybe you can like degrees a little bit better. So exercise 12, that says, take a look at 420 degrees. So my key number is 360, because that's a full rotation. So if I have to find, I'll write it here lower, cosine of 420, then I'm going to break this with a 360 and whatever is left. So if you take 360 with 60 and add it, you will get your 420, right? So this stands for doing the rotation all the way around, that's 360, and another 60, somewhere here, approximately. So this is going to be our angle. And notice this is same as if we just deal with 60 degrees, right? So we care about cosine of 60 degrees. So let me try to check the last page of this textbook, go back to my favorite little diagram here, and find this angle, which is 60 degrees on it. And looks like 60 degrees angle is right there. So I'm concerned with this point. So what do I need? X or Y coordinate? Cosine is X coordinate. So cosine is the first one, cosine of 60. Or cosine of this 420, because when you add period to it, it stays the same. So how about if you try exercise 11 for a little quiz for today? Just don't hurry, please. And the hint is, look at exercise number 19, will be very, very similar answer. So quiz for today, exercise number 11. And the process that I just outlined here is going to be used. So you need to since it ends with a 5, so something that deals with 45, right? And that's the idea. So I'm gonna stop to record, and please take your time. And as usual, just